Proportional Reasoning, Lesson 8, Part 2. Direct Variation Notes. Okay, direct variation y equals kx. Here are the vocabulary terms. Direct variation, a relationship between variables in which one variable is a constant multiple of the other. Direct variation equations, or direct variations, can be written in the form y equals kx. For example, d equals 20t. D is always 20 times as big as t. X over y equals 3. X is always 3 times bigger than y, because y equals 1/3 of x, so y is 1/3 the size of x. 3h minus t, because t will equal 3h. T is always 3 times bigger than h. The constant of proportionality. The value of k in the equation that represents a proportional relationship, y equals kx. Also, the ratio of quantities in a proportional relationship. For example, 3.5 in the equation y equals 3.5x, 8 in the equation a equals 8h, 9 in the equation v equals b times 9. An inverse variation, now this is just for your information, it's a relationship between variables in which the product of the variables is constant. Inverse variations are of the form y equals k over x. For example, s equals 3600 divided by t. That's actually your speed in miles per hour given the time in seconds that it takes you to go a mile. That is an inverse relationship. Phi equals RT is another example of an inverse relationship. No matter what, R times T equals 5. Direct variation is another way of representing proportional relationships using multiplication. When x and y are in a proportional relationship, the ratio to y to x remains constant. Y over x will equal k. K is the constant of proportionality. Multiplying by x on both sides gives the direct variation equation. So see that we have y over x equals k. As we multiply both sides by x, it gets rid of the x from the bottom of this fraction, and we are left with y equals kx. So this equation comes directly from the idea that the ratio between x and y are constant. That's what makes it direct variation. Okay? And it is another way of saying they're proportional. Determine whether x and y show direct variation. If so, state the constant of proportionality. If not, explain why not. First example, y equals x plus 1. Now, some things we talked about in the last video is you've got to be able to get it in the form y equals kx. Y equals a number times x to make sure it's direct variation. You can also check some other things that we know about proportional functions, or not functions, proportional relations. It would have to go through the point 0, 0, which we can try in 0, 0 and see if it works. So explaining two ways. First, the plus 1 makes it not direct variation. So we'll go with that. The plus 1. The plus 1 is not in y equals kx. Another thing we can notice here, if you plug in 0 for y and 0 for x, you get 0 equals 1, which is false. So we know that it doesn't go through the origin. If it doesn't go through the origin, it's not going to be proportional. Y equals 14.5x. All right, on this one, it's looking pretty good. It's y equals a number times x. That's actually exactly what it needs to be. My explanation, I'm going to state the constant of proportionality. Well, the constant of proportionality here is just 14.5 because it looks exactly like y equals kx, where k is just 14.5. Another thing that you can notice here, if I plug in 0 for y and I plug in 0 for x, I get 0 equals 0, proving that it goes through the origin. Next, xy equals 60. All right, on this one, it may not be immediately clear. If we plug in 0 for x and 0 for y, we get 0 times 0 equals 60, which is false. It does not go through the origin. So this would be no. 0, 0 not included. But there's more to it than that. If we try to solve for y here, we'd have to divide by x, and we get y equals 60 divided by x. This is actually an inverse variation. Okay, let's look at a table here. The example 374, hours, 1, 2, 3, 4, gallons, 250, 500, 750, 1,000. Okay, I don't see 0, 0 in the table, so we don't have that quick check. But let's go ahead and just see if everything, all the ratios are the same. If we do 250 gallons in 1 hour, that's 250 gallons per hour. If we do 500 gallons in 2 hours, that's 250 gallons per hour. 750 gallons in 3 hours is 250 gallons per hour. 1,000 gallons in 4 hours is 250 gallons per hour. So this is definitely proportional, so it definitely shows direct variation, and the constant of proportionality is just that ratio, 250. Okay, let's look at example 375. We've got seconds versus height. Looks like something's going down. I'm going to notice right off the bat that it does not include 0, 0. So there's no way it could be direct variation. Okay, example 376. I see a straight line. It does go through the origin. This is proportional, therefore it is direct variation as well. For direct variation, we're going to have to find the slope here. It goes up 4 and over 3. So the slope is 4 over 3. And the constant of proportionality is 4 over 3. Consider the perimeter of several regular hexagons. Write a direct variation equation that relates the side length S to the perimeter P. Alright, I notice that if I take the ratio of P to S, I get 6. 24 over 4 is also 6, 36 over 6 is 6, and 48 over 8 is also 6. So my constant of proportionality here is 6. Now I'm not using y and x, I'm using p and s. P equals 6s. This would be the direct variation equation relating p to s, or s to p. Use your direct variation equation from example 377 to determine the perimeter of a regular hexagon with a side length of 11.5 meters. Well, since it's telling us side length, that's s. S is 11.5 meters. So we're going to have P equals 6s, but instead of s, we're going to put 11.5 because we've been told what it is. And if we just multiply that real quick, 6 times 11.5, we get that the perimeter is 69 meters. Okay, example 379. Use your direct variation equation from example 377 to determine the side length of Saturn's North Pole regular hexagon with a perimeter of 87,000 kilometers. All right, this time we're given the perimeter to be 87,000. So we're going to plug in 87,000 for P, and that equals 6s. So we'll just divide to get s by itself here. So s equals, well, 87,000 divided by 6 is 14,500. So the answer here would be 14,500 kilometers. That is a very large hexagon. The equation y equals 35x represents the distance traveled, y miles, by a train in x hours. Interpret the meaning of the constant of variation. All right, this is where we interpret that 35 has meaning to it. And there is a unit, it is a unit rate measured in y per x, miles per hour. What it means then is that the train, well, I probably should spell train, right? The train travels at 35 y miles per x hours. The train travels at 35 miles per hour. That's what it means. Okay, in the practice on this, you're going to tell whether x and y show direct variation. If it, explain why, or why not. If it does, you need to find k. By the way, if you can find k, that's explanation enough that it is proportional. Number 2, it's a situation about buying concert tickets, and there's a unit rate problem involved here. Number 3, review of factoring GCF. Number 4 is substitution. You're going to plug in x is 1, y is -5, and simplify. Number 5 gives you a direct variation equation, m equals 4t, and asks some questions about it. Remember that m represents the mass of the tree in kilograms and t represents the age in months. And number 6 is a unit rate problem dealing with buying pecans and peanuts. Number 7, consider the ruler shown. You write a direct variation that relates x inches to y centimeters. The unit rate there, by the way, is 2.54 inches per, or centimeters per inch. Then find the smallest values of x and y so that x and y are both integers. Okay, and that's going to take some careful thought. You might take the conversion ratio fraction and try to simplify it so that the top and bottom are integers. Right now it would be 2.54 over 1. And then number 8 is a question about inverse variation, having you make some comparisons here. It looks like they're actually both talking about the 100-meter sprint. One, the world record, and the other, the Utah State High School record.